Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the remove duplicates from sorted array problem. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of num should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slot of nums. Do not allocate extra space for another array. You must do this by modifying the array input in place with order 1 extra memory. There's a custom judging algorithm. It just basically says it'll check the first k things and it'll ignore the rest. So 1, 1, 2, we need to remove that other 1, so we end up with 1, 2. And the first 2 elements are left, and this is junk. Here we need to be left with 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And it's a whole lot of other junk. So the trick here is that we see non-decreasing order. Now this is just a fancy way of saying it goes up, but it says it in a particular way. It says non-decreasing rather than increasing, because we can have duplicates, which is the whole point of the problem. 1 is not greater than 1, but it is greater than or equal to 1. So if you were to look at this like a graph, basically we can have horizontal sections, but we can never have bits that slope down. Let me try that again. If we think of this as a graph, we can have sections that slope up. We can have sections that are horizontal, but we can't have sections that slope down. Not allowed. This is the same problem we've done twice already this week. It's a stack problem. It's because of this non-decreasing thing. So we've talked about this. If I have a plate with some pancakes on it, I can push things onto the stack. I can put the pancakes on top. I can take pancakes off. And I can do that as much as I like, but I can't reach into the middle of my stack of pancakes because that'll be a syrupy mess. How does that work for this problem? Well, let's think about this 1, 1, 2 example. I'm going to put the 1 on to my plate. That's my first pancake. I see the next one and I realize, oh, there's no point putting that on because I've already got a 1 on there. So I'm going to not put the 1 on. And then I put the 2 on, and that's fine. No problems there. And of course we'll have junk left over. With this second one here, I push the 0 on. I go to put the next 0 on, but I realize it's a duplicate. I put the 1 on, that's fine. I go to put the next one on and I realize it's a duplicate. I go to put the next one on and I realize it's a duplicate. I put the 2 on, it's fine. I put the 2 on, I realize it's a duplicate. I put the 3 on, that's fine. 3, realize it's a duplicate. 4, and we're done. So, exactly the same algorithm that we've already done today. So what we need to do is we need to maintain a top is -1. And what I want to do is I want to return the top when we get to the end there. But it's for int I equals 0, I is less than num's size, I plus plus. And if you remember yesterday's video where we were dealing with a string where we had to remove duplicate letters, here we're not duplicating both. We're not removing all the duplicates. We're not getting rid of all the zeros or all the ones. We're just getting rid of most of the zeros, most of the ones. So if top is less than 0, top gets incremented because that's the spot I'm now going to fill in. I am going to put something onto my stack, and it's going to be nums size at top is equal to nums size at position I. That is my push the thing that I'm focusing on to the top of the stack. Else, in fact, no, we're not up to an else yet. That's one case where I want to push onto the stack. The other case where I want to push onto the stack is when nums size top does not equal, oops, not num size, just nums. I made that mistake in lots of places, didn't I? There and there. If the thing on the top does not equal the thing I'm currently focusing on, so the 0 does not equal the 1, that's okay. So we can put that on. Otherwise, what I want to do is, well, basically nothing, isn't it? I don't want to push something on, so I'm not going to do this increment. But unlike last time, where we had to pop something off as well, I'm not doing any popping here. So that's perfectly safe to leave as it is. Now the trick here is my top off by 1. So let's do a little run through with it. So let's say I have nums is equal to 1, 1, 2. I is equal to 0 and top is equal to -1. So first loop, I is 0. We're focusing on this thing. Top is less than 0, correct. So we're in this case here. Top gets incremented to 0. Nums top equals nums I. So that's nums 0 equals nums 0. Fine. Done. I goes to 1. Top is not less than 0, but and 1 equals 1. Nums at position 0 does equal nums at position 1. So we're not going to do this. We're just going to continue on as we were. I goes to 2. Top is not less than 0. Nums top. Nums 0, so the 1 here does not equal the 2 here. So that's good. We're going to increment top, and we're going to put nums top, nums 1 is going to be equal to nums I. So that gets written there. And then we're done. So I'd actually need to return top plus 1, because top tells us where we finished looking. But we need to return the length, and the length is 1 longer than the final index. When you're learning programming, that's always one of those things that's a bit weird. If I have a list of length 3, I have the indices 0, 1, 2. So my top index was 2, my length is 3. Right, let's run some tests. First one, it's the one we just ran through by hand. Looks like it's working great. Let's have a go at this one here. I clicked the button too quickly. Silly. You went, no, that's not what happened. You were not signed in. Reload. Run code. I am signed in. I know for a fact I'm signed in. Use all example test cases. Run code again. Perfect. Both seem to work absolutely fine. So let's submit it. See what happens. If there's an edge case we've missed, it's hidden. We haven't missed an edge case. Excellent. So that is day 3 this week of stack-based problems. When there's a theme, there's a theme. What can I say? At this point, I think we all kind of know how to do these, so hopefully Leetcode's going to get off our back about this. Anyway, hopefully you now have a very good understanding of how stacks work and how they can be used in algorithms that you don't initially think they will be used in. Like removing duplicates doesn't seem like a stack problem at all, but in this case it absolutely was. Anyway, do remember to like, comment, subscribe, all of that good stuff. It really does help the channel. We're over 50 subscribers now. Just yesterday I was saying we're nearly at 50 subscribers. We're over 50 subscribers, and it's I just can't believe it. Thank you all so much for your support. I do hope you have an amazing weekend. You've all definitely earned it, and I will see you next time. Bye.